Okay, as we move towards the second experiment, again it involves the LU decomposition, where you're going to solve a matrix. Not like unlike the previous experiment where you're just going to display the L and U matrix. It is not like that. You're going to solve the matrix. So definitely it is kind of a linear equation. So you're having the linear equation and you're going to have the output as the solution for your linear equation like x, y, and z. So you have to understand that your matrix is already given by the system, which I can translate it as 3x plus 2y plus 7 is equal to 4, and 2x plus 3y plus 1z is equal to 5, and 3x plus 4y plus 1z is equal to 7. So this is your equation and you have the expected result like this. So don't worry about the input, the system will automatically give it to you. And as always, you have to give the environmental variables here, which is not displayed here. You have to definitely put that, and then you are going to import the numpy as np, which is by default for all mathematical calculation you require the numpy library. And then again, like in the previous experiment, you are going to import the scientific python library, from which you need to have only these two functions, which is the lu factor and the lu solve. Afterwards, what you do is you will be giving the declaration of the array, that is your array will be the matrix will be got from the system, that is you are giving an input function which is again being embedded inside the evaluation function, and finally it is converted into the numpy array. So three functions are there, and similarly you are going to get the constant part b again through the same way. Okay, and afterwards you are going to call the function lu factor. Okay, so this will again give you a value known as lu in return, and also a pivot element as the second value. Okay, so after you got these two values, you need to have this lu as well as the pivot to be entered into the arguments of this function lu underscore solve, along with the constant part. So these are the functions that is being previously got from lu factor, and that you are going to again send as an argument in the next function, the lu solve. And finally you're going to solve, you're going to send one more value, which is b, and finally you'll be getting the solution of this equation. Okay, so this is an intermediate step without which you will not get the answer for this. So finally you're going to print this and you're done. Thank you.